Hello all, welcome back to my YouTube channel all about VLSI. This is project development series using Verilog and this is project development series part 2. In this particular session we are going to discuss about a design which is a RAM. Basically it stands for random access memory, and especially we are going to discuss about now, what do you mean by a single port RAM? Now, in this single port RAM, we have only one port for writing and reading the data. That means, let us see the block diagram of this single port RAM. It is going to have a clock, a reset signal, and a write enable, a read enable. And we have a signal which is known as data signal. This data signal is a bidirectional signal from which we can write the data into this RAM and from which we can read the data into this from RAM. Okay, and we have only a single address pin. Okay, so this is nothing but my single port RAM, and again we are going to consider a simple 8x8 single port RAM. Now this RAM basically works on the positive edge of the clock, and if we apply the reset signal, all the memory locations will be get reset. So total we have 8 number of locations and each location width is 8 bit. Now if we want to write any data into this RAM, we should make sure that our write enable is equal to 1. Then only we can write the data into this RAM. Now how to write this data? How to write the data into the RAM? We are going to use a signal which is known as data. Okay, this signal we are going to use, this particular bus we are going to use, and we are going to write the data into this RAM. And if I want to mention at which address location I want to write the data, using this address signal I am going to mention. Let's say this is my memory where I am going to have 8 number of locations. Let's say if I want to store it in 7th location, then I am going to mention using this address signal so that my data will be stored in this particular address location. Okay, so unlike your FIFO which we have discussed previously, this RAM can we can access random locations. That's why it is known as random access memory. But your FIFO, it's a sequential memory. Okay, now and we are going to provide the data and to which location we want to write or from which location we want to read that particular thing, we are going to mention the address, right? So this is nothing but my single port RAM signals which are related for writing and reading the data from this memory and for accessing the data from this memory, right? Now we are not only going to implement this simple RAM. Now what are we going to do is we are going to have this blocks. How many blocks we are going to have? We are going to have 4 number of blocks like this, 1 2 3 and 4. Okay, now each block is of 8x8, 8x8, 8x8 and 8x8. So total 8 8 16 24 and 32. So we are going to connect this 8x8 blocks so that we are going to make it as a 32 number of locations we are going to make it. Okay, and we are going to select each location. This each block is going to have write enable and read enable, write enable and read enable, this write enable and read enable, write enable and read enable. Like this we are going to have, right? Now what are we going to do is we are going to have a simple decoder circuit, and this decoder circuit is for basically, and this blocks, the RAM blocks are going to have one more signal which is known as chip select. Okay, so that we are going to select, so that we can able to select at which block we can or which RAM we want to work with, right? So we are going to take a simple decoder which is nothing but 2x4 decoder, and this decoder outputs are connected to this chip selects like this. So this decoder outputs are being connected to this chip selects. Okay, and we are going to have a 2x4 decoder, and the input of this 2x4 decoder is, let's say, I0 and I1. So the user is going to provide this address, 2-bit address to this decoder. let's say if the user provides the 2-bit address as 00, then let's say this RAM first block is 00, 01, 10 and 11. So if the user provides the address as 00, then the decoder will select this first block and your user is going to basically communicate with this first block. Okay, let's say if your user is providing address as 01, then the decoder basically activates the CS pin of the second block and the user is going to communicate with the second block of RAM. Okay, like this your decoder is going to help you the user to communicate with which particular RAM block. Okay, this is what we are going to implement. Let us try to understand with the help of coding how to do this particular thing. First of all, let me create the file of my RAM _8_8 and press OK and finish. Write enable is one of the signal, read enable is one of the signal, and chip select also we are going to have is one of our signal, and we have inputs as write address. So for 8 locations we need 3-bit write address and only address, sorry, so we are only going to have one address signal. Okay, and our input as 7 down to 0 data, and this is an in-out port which we are going to have in-out port data, and the output which we are going to have output, sorry, we have already taken this in-out port, right? That's it. Clock, reset, write enable, read enable, chip select, address and in-out data. Now, so we are going to write down first of all our always block @ of clock begin. If we apply this reset, then let me create an internal memory reg 7 down to 0 mem 0 to 7 is my memory I have created. Now if reset, my mem is equal to 0. Else if I apply my write enable and if my chip select is equal to 1, if my chip select is equal to 1, then only I am going to write my data into the specified address. Or else what I am going to do, first let me declare one internal register temp underscore data which is of 8 bits width, 7 down to 0. Now chip select and read enable, or else we can only take one signal. Some designs only have write enable only, so we will take that particular thing only. So CS and not of write enable, CS and not of write enable, then I'm going to store my data from the memory mem of address. Okay, like this I'm going to store it. Okay, and followed by end. Now so mem of I, so I'm supposed to use a for loop for I is equal to 0, I less than 8 number of locations, I equal to I plus 1, mem of I is equal to 0. If I apply my reset, integer I. So this is my simple RAM module which I have developed. Now, so I need to read also, right? So how I'm going to read, assign data is equal to, if my chip select is equal to 1, and here I am going to take one more signal for my RAM, that is nothing but out enable. So I'm what I can do is, let me draw it one more time. This is my RAM and clock, reset and address, and I have write enable. If this write enable is equal to 1, then I can write the data into the RAM, and if my write enable is equal to 0, then I'm going to read the data from this RAM, right? Now I'm going to take one more signal which is known as out enable. If this is equal to 1, then I can read the data out of this RAM. So if my out enable is equal to 1 and write enable is equal to 0, then only I can read the data from the RAM, and also my chip select is equal to 1. And if my out enable is equal to 0 and write enable is equal to 1 and chip select is equal to 1, then I can write the data into the RAM. Okay. If this is equal, if this condition, then I will read the data, or if this condition is filled, then I can write the data. Okay. Now that is what I'm going to implement over here. I'm going to add this signal which is known as out enable. Input out enable. Okay. So I'm going to write it down O enable OE. Then if these conditions are met, then I'm going to read the data out of this RAM, or else I'm going to return Z. And followed by the last condition, that is our data which is equal to write enable if it is equal to 0 and chip select is equal to 1 and O out enable is equal to 1, then my data value will be equal to temp underscore data, or else it will be connected to high impedance. Okay, this is what we have written inside our code. Now coming to our test bench. Our test bench is a simple. So first we are going to declare the signals, and here we need to make sure that we have declared the data as wired data type, because we have already studied in our playlist also the in-out connection should be connected with a wired data type but not a reg data type, right? And we have instantiated our design, but here what I'm going to do is I'm going to take one more variable as reg so that I can use it in procedural blocks. Okay, and I've initialized my variables within an initial beginning block, and I've generated my clock and reset condition I've applied. Now what I'm going to do is I'm going to provide write enable is equal to 1, chip select is equal to 1, and data underscore temp is equal to this data I have provided, and address is equal to 0, so that the data will be written into that particular address location. And next what I have done, made my write enable to 0, chip select is still equal to 1, and address is equal to 0. That means I'm trying to read the data from my RAM, and also I make sure that out enable is equal to 1 so that I can read the data out from my RAM. And I've called the finish, and also I'm going to write assign data is equal to data underscore temp. So whatever the data underscore temp we are going to give it here, that we are going to assign to our data. Okay, so that we can write the data into the RAM. Okay, that is what we are going to do here. So let us see the test bench results. So we have generated our clock. This is our clock we have generated, and reset if we have applied all the memory locations are got reset, and write enable was equal to 0 still, chip select is also equal to 0, and out enable is also equal to 0. Now whenever your write enable is equal to 1 and chip select is equal to 1 and O enable is equal to 0, that means you are writing something into your memory. Now, and your data, you can see over here it is equal to D7, that means you are writing into the address 0. Okay, now let's say if you want to read the data, then you are going to make your write enable equal to 0, but chip select and out enable are equal to 1. That means you are trying to read the data out of this RAM. So how you are going to read? So from here we are getting our data, see. So on the same line we are getting our data. Okay, so this is how we are going to write and read from our single port RAM. Now what is our requirement? Our requirement is to have multiple single port RAMs, right? Now in the test bench only I'm going to instantiate multiple single port RAMs. Let us see here. Let's say this is as DUT1, DUT2, 3 and 4. Okay, so this is my DUT2, 3 and 4. Okay, and let me save this so that you can see over here in the sources 4 blocks will be added. Like this 4 blocks are added. Now we need a decoder, simple decoder logic. So I'm not going to write down a decoder module separately. I'm going to write it down in the test bench itself. Now how I'm going to write it down, let us check it out. So within an always @ I'm going to check for my address. If my address is equal to 0, then now if my address is equal to 0, then my CS1 and let me take it as a reg so that I can use it, right? So if my CS1, if my address 1 is equal to 0, then my CS1 is equal to 1 tick binary 1. Okay, 1 tick binary 1, and CS2 will be equal to 0 only, and CS3 will also be equal to 0, and CS4 is also equal to 0. Okay, rest all signals are equal to 0. And but if your address is equal to, let's say, 2 tick binary 0 1, okay, here we will change it 2 tick binary 0 0. Okay, if your address is equal to 0 1, then your second RAM should be selected. I'm going to write down over here CS2 is equal to 1 tick binary 1, and remaining all will be equal to 0, and I'm going to write it down within a begin and end block. Now let me copy this and let me write down the logic for the third block of RAM. How to write it down? Same. But if my address is equal to 1 0, then I'm going to make this CS3 as equal to 1 and remaining things to 0. Okay, and let me copy this and paste it over here, 2 tick binary 1 1. Then CS4 will be activated and CS3 will be equal to 0. And let me save this and run this. Now you can check out here, this is my DUT instance 1, and I have taken my chip select and I have given my address is equal to 0 0. You can check out here, the address is equal to 0, so that your chip select 1 will be activated, right? And you can see in the DUT1 block, the memory has been written. We can see the data which is present here in the memory. But in the DUT2 block, there is no memory which is present over here. You can see it. So in DUT2 block, there is no memory present over here. And in the DUT3 block also, you can check it out, there is no memory. And DUT4 block also, there is no memory. No data has been written inside this memory. Okay. Let's say, let us try to change the data. Let us try to change the address. Let us change it to 2 tick binary 0 1. And let me save this and run this again. Now, here DUT1 block, you can see no data has been written, and DUT2 block data has been written. We can see it. And DUT3 block, there is no data written, and DUT4 block also there is no data written. And if we want to more precise about our chip selection logic, then we can do one more thing also. What we can do is we can take the address bit, and in the 8 bits we can choose the MSB bits for slave selection. What do I mean? So address of, so here the address is of 3 bits, right? Now we can allocate 2 more bits for chip selection logic. What do I mean? So the 3 bits are used for selecting 8 locations, right? And I am going to add 2 more bits so that my address will now become of 5 bits. Okay. So what I'm going to do is 4 down to 0. Now here 4 down to 3. If it is equal to 0 0, then I'm going to select this block 1, and the remaining 3 bits are used for selecting the location. That is what I'm going to do. Okay. So this 4 down to 3, if it is equal to 0 1, I'm going to select this block 1, and the remaining 3 address bits which I have, I can use it for selecting the particular address location. Like that, I can select a particular RAM using the first MSB bit and the next bit, and for selecting the particular location, I can use the remaining 3 address locations. So that's all about this particular development, and in our next session we are going to see about another project. So I think you have understood how we are going to work with different RAM blocks using this chip select signal. If you like this video, please like, share and subscribe to my YouTube channel all about VLSI. Thank you for watching this video.